In this section, we're mostly going to be concerned with graphing these polynomials. We did this in an earlier section, so I won't spend a lot of time on this. The graph of x cubed, as I recall, starts at the origin, comes up here, similar to a parabola, but goes down on this side. So the plus 1 at the end shifts the whole graph up 1 unit. So it will look like this. Very similar to the previous one, we know that an x to the 5 is similar to x to the 3. As a dot at the origin goes up to the right, and is going to be skinnier than x to the 3, down to the left. So very similar looking to x cubed. And the graph of x minus 2 is going to be shifted to the right 2 units. So that dot that was at the origin will begin here. It will go through these 2 points, 1 unit over, 1 unit up. We can do this from what we have learned previously. I will mention, however, that this is a 4th degree polynomial. We know it's shifted up 5 units and shifted to the left 3 units. It's going to be upside down, and it's going to be squeezed down. However, just like we did before, we can recognize that this is a 4th degree polynomial. 4th degree polynomial is going to be like x squared. It's going to go through the origin. It's going to curve upward on both sides of the origin. So let's see what our shifts will do. The negative on the front is going to curve it downward instead of upward. And the 1/2 is just going to squeeze it in. So the 1/2 is going to make it a little narrower. Then the plus 5 shifts it up 5, and the plus 3 shifts it to the left 3. So here is to the left 3 and up 5. So this should look like this. Now we could just do this on our calculator. We just talked about this in the previous problem. X to the 4 is similar to x squared in that it looks like a parabola. However, the minus on the front tells us that it's upside down. Now the symbols that they're talking about using for the end behavior are simply these. This graph is going to be going down on the left and down on the right. So that's how we would answer the problem. Likewise, x to the 3, since there's a plus on the front, is going to be going up on the right and down on the left. So these are the symbols we would use. So on this one, the x to the 5, we mentioned this earlier, is similar to x cubed. Its graph would look like this. where it's going in opposite directions. Now the minus that's on the front just tells us that the directions are reversed. So on the left it's going to be going up, and on the right it's going to be going down. X to the 6 has similar characteristics to x squared. It's going to be going up on the right and up on the left. So to graph this on our calculator, we start with the y equals. We'll clear out anything that's there. Then type our new one, 2x cubed plus 3x squared minus 11x minus 6. We will do zoom 6 to start with a standard graphing window. Now we know basically what this graph should look like. It should have the right side going up and the left side going down, which this one does. We do, however, just need a little bit of adjusting in the window so that we can see the top peak and the bottom peak. And so on our window setting, we will change the y min to something lower than -10, like -15, and likewise the y max to a +15. Here is the graph, and you can see now we have the entire graph. Now if we're needing to transfer this, say, over to the computer for a problem where we're needing to draw one of these graphs, we can look at the table of values. Using second table, we can get a lot of different values, such as right here, the x-intercept, using the calculator as our guide. We know that there are x-intercepts at 2, 0, -3, 0, and there's a y-intercept at 0, -6. Now you just saw what this looked like. The line was coming up from the bottom to this point. It was going on up, and I'm not going to go all the way as high as it's supposed to go, down through this point, and then over through this point. So again, that's just a rude sketch of what this would look like. A few more points added in here, and we'd get a better picture of the graph. So you could use a similar technique to the previous problem. However, we can tell that there's an x-intercept at -2 and at 1. Those are the only two x-intercepts. So we'll put us a dot here at -2 and a dot at 1. Now again, we don't know specific other dots. Again, this is where a calculator would be helpful. But we do know that x to the 3 times x to the 2 gives x to the 5. So this is a 5th degree polynomial. It has to be going down on the left. We will assume that this just goes down forever. And it has to be going up on the right. Now the significance of these are the odd number 3 on the -2 tells us the graph goes through that point. The even number as an exponent on the x equals 1 tells us the graph bounces off of that point. So there's our sketch of the graph.